it'd be a problem. I think it just went off, but we're gonna see. If not, I'll have to figure out a way to get the first 8. Okay, so again, the 3 differences between a compound and a mixture. The first one is compounds combined in a definite weight ratio, the log definite composition, whereas mixtures combined in any weight ratio. The second one, a mixture can be separated by physical means. A compound can only be separated by chemical means. What are some physical means of separating? Evaporation. So in other words, you have salt and water, we just evaporated the water off. Filtration.
Sieving.
What?
Sieving.
What does that mean?
This is like they create is like a rod, and you pour stuff down the rod. Like the water went down, but other stuff like stay on the rod.
Oh, really? I've never, that would be physical, but I've never seen that. I learned something, so appreciate that. Okay? I had that distillation apparatus set up where you evaporate the water off and then collect it. So distilling, that's really kind of like evaporating. Okay? Magnetism, using a magnet to separate. And when you put, you know, when you recycle, there's tin cans and there's aluminum cans. A lot of the vegetables come in tin cans. Sodas all come in aluminum cans. So it goes to the recycle plant. The first thing they do is pass it under a big magnet. And the magnet will take all of the tin, and aluminum doesn't attract to a magnet. So they can separate the tin from the aluminum just with a magnet, and then put the tin over in one pile, let the aluminum keep going up the conveyor belt as it goes. Okay? And so you can separate that. So those are good. Those are, and then the third one. Okay, Madison?
In a compound, there's evidence of a chemical change when the components combine, and in a mixture, there's not.
That's right. Evidence of a chemical change in the formation of a compound, but not in a mixture. What are evidences of a chemical change? We should probably know this as well. Change in odor. Not just that it has an odor, it's a change in it. What symbol do we use for change? The little triangle. It's the Greek letter delta. It means change in. That's in the notes. Okay? Change in odor. What else? Change in color. Think of the black turd experiment. Okay? How all did we know something was happening? Change in color, change in odor, bubbles, which indicate the formation of a gas.
Heat's produced.
Heat will change in heat. If heat's produced, the surroundings get hot. That's an exothermic. What happens to surroundings in an endothermic? It gets cold. Okay? Because the kinetic energy of the surroundings is going in to break the bond, being absorbed as potential energy, which a thermometer doesn't measure. Okay? All right. Highly recommend. You know that well. Okay? What is the difference between homogeneous and heterogeneous mixture? Okay? Go ahead, Taylor.
You can see the different compositions of each.
In which one?
And heterogeneous.
In heterogeneous, you have different phases, different parts with different properties. Whereas in homogeneous, single phase, only one set, you know, so Kool-Aid is red all the way top to the bottom, or purple, or green, whatever color Kool-Aid. Okay? But chicken noodle soup, when you look at it, you've got the broth, and you have the noodles, you got the chicken parts, and you got a little grease floating on the top, and all the different parts of chicken noodle soup. Okay? So I just gave you examples of each. All right, what happens to the surroundings during an exothermic reaction? We just said it. What happens to them? It gets hot. And what happens in an endothermic? It gets cold. Okay? Oh, you just moved it up. You tricked me. I kept looking down here. I said, where'd that go? Okay? So, we just talked about 5 evidences. So that was heat. Okay, so what are some other evidences? So we have change in odor, change in color, change in heat, which is either hot or cold. Light given off, okay, that's the fire that we see.
Precipitation.
The forming of precipitate. Now, what is a precipitate? No.
Like condensation.
Kind of like condensation, but not really. So here's a test tube. So I put some of this blue copper sulfate. Notice it is clear. It's blue, but it's clear, right? You can kind of see through it. It's clear. Okay? Now if I take some sodium hydroxide, NaOH, another clear, colorless liquid, and I mix these two together, now all of a sudden, is it clear anymore? Can you, what's forming on the inside? It looks like a solid, right? Because it is a solid. It's a precipitate, an insoluble solid that forms during a chemical reaction. That implies, hey, this didn't just mix with this. Something happened chemically. Okay? And this is kind of forms kind of like a Spain Park blue, go Jags. Okay? A little bit more of a royal blue, but looking up here, it's kind of the lighter blue. Okay? But it's definitely a solid. You can see the solid collecting on the sides of the test tube. So that's what a precipitate is, an insoluble solid that forms during a chemical reaction. Tells me, hey, something happened. Okay? What are the differences between a solid, liquid, and gas in terms of an atom's or molecule's positions and bonds? So in a solid, how are the atoms positioned as far as distance-wise? Really close. How close?
Really close.
Really close. Like how close?
Like
Almost
touching.
Like right next to one another, right?
Yep.
They're not just kind of close, they're right next to one another. They're incompressible. You cannot push them any closer together. They're as close as they can get. Right next to one another. But what about the pattern? What about how they're arranged?
crystalline.
Crystalline meaning what?
It's a uniform composition.
It's a, well, uniform,
No, it's
let's not say uniform. I understand what you're saying, but let's get a better word than a uniform composition. Crystalline. They're arranged in rows. They're arranged in an orderly pattern. Okay? So it's orderly, it's crystalline. What's the opposite of crystalline?
Amorphous.
Amorphous. That would be random. Okay, so then a liquid. And so obviously solid atoms are bonded fairly strongly. Okay, they're held rigidly in place. Okay? What about a liquid? How are those molecules arranged relative to one another?
Close, but they're not like touching.
Bonds.
Is a liquid compressible?
Yeah.
Wait, no.
No. So what does that mean about its molecules or atoms? They're right next to one another. Again, you were taught in middle school, and I know that it's in your head, solids are right next to one another, liquids are a little bit farther apart, and gases are very far apart. But that is not true. Liquids are incompressible. So how are the atoms or molecules in a liquid arranged relative to one another position-wise?
Not.
Wait, but that's going to be how they're arranged. But as far as distance-wise, they're still right next to one another, as close as they can get because they're incompressible. But what about their arrangement? Is it orderly? No. It's an amorphous arrangement. The molecules are rolling around one another. You've given them enough energy to where you can break the bonds holding them in place in a solid, and now they have mobility, so there's no longer any order. So the only difference between a solid and a liquid is an orderly arrangement where they're held rigidly in place versus a liquid, they're still right next to one another, but they can roll around, they can move. Okay? I highly recommend that you know that. Okay? What do you think that's code for?
See it in the near future.
You're gonna see it in the very near future, that's exactly right. Okay? And then what about a gas?
They're far apart.
They're far apart. Okay? And so gases are compressible. They expand to fill the size of the container, and you can push them closer and closer and closer together. Okay? So, and there's basically no well, there's attractions, but there's enough energy to overcome those attractions. The attractions are minimal in a gas. All right. So we just defined all these words. Pounded into these, pounded into thin sheets, okay? Drawn into wire, orderly arrangement, random arrangement. All right, so what does 2H mean versus H2? Taylor.
Okay, so, H2, like the subscript two, it's how many, like, not atoms, cause like how many, okay, H2 is how many atoms it is, the subscript, and then the
Right.
coefficient is how many elements there are. Does that make sense?
Kind of.
Like, so there's
2H is gonna mean I have two hydrogens that are completely separate, not bonded.
so
Okay?
that means
Two separate hydrogen atoms, just single H atoms. But H2 means that they're chemically bonded together. Now I have a molecule, one thing, that has two hydrogens in it. Okay? So if I said the same thing with H2O, okay? I have one water molecule, so I would say just H2O. But that molecule has two hydrogens and one oxygen. But if I said two H2Os, what is that gonna mean?
four hydrogen, two oxygen.
Right, but it's gonna be two separate, they're not gonna be bonded together. So I would just build another water molecule. So thank God I didn't put this one too much apart. Okay, so now I have two individual water molecules. Each molecule is H2O. Alright, so we see that? Everybody, we see that? Pay attention at home, wake up. Alright. Being able to explain their function, for example, so we just did that. Pure science and applied science, knowledge for knowledge's sake, technology, using science to meet the needs of society. Okay? All right, so we already kind of talked about this. Identify, list, physical means of separating. Let's go through it again. Filtration, evaporation, distillation, magnetism, even separating by color, would be a physical means of separating. Okay, chemical means would be using electricity to decompose water, doing a chemical reaction to precipitate a metal out of the solution, heating something up to make it decompose. Okay, those are all chemical means of separating. And know the rules for chemical symbols. Okay? So the first letter is always,
Upper, capital,
and the second letter is always lowercase. So the difference between CO and CO. This is what?
cobalt,
Cobalt. This is an element. Cobalt. What's this?
Carbon oxygen compound.
It's a carbon-oxygen compound. Anybody know the name of it?
Carbon monoxide.
Carbon monoxide. I don't know if that's what you were saying. I just heard a mumble, but carbon monoxide. What does the mono mean?
one,
Only one. So what's carbon dioxide?
two,
CO2. So this is carbon monoxide. You don't say monoxide. There's only one of them. Carbon monoxide, but this is a compound. Okay? So that's why we have to make sure that the second letter is lowercase to differentiate between an element and a compound. Okay? Now, where does some of the names come from, like sodium, Na? From the Latin, okay, or some other, usually from the language it's derived from. For instance, tungsten, number 74, is W, and that comes from Wolfram, which is a German name for it, okay? So, how many elements are there?
118.
118, but only the first 92 are natural. Really, there's only 90 natural elements, because element number 43 and 61 are both man-made. The outlying ones are man-made. They don't exist in nature. Okay? 43 is right in the middle, technetium, and it's called technetium because it was one of the first man-made elements. Okay? And then number 61 is promethium, and that's actually, they have located this in stars. And when we learn about light, we'll talk about how they can identify elements. Okay? So, does anybody have any question about the test, what you need to do, what's going on?
Would the short answer questions be like, I don't do any in the lab? Would that be like something that,
What did you just say, like what?
like the short answer questions?
I know, so what was your example?
Would that be like the stuff that we learn in the lab?
Some of it could be, okay? Could be things that I kind of highlighted here today, okay? I will just say that everything that we talked about today, well, everything on the, let me say it this way, everything that is on the test, we have talked about today. Okay? So, any other questions? So what time are we gonna start taking that test? 1 o'clock. When's it gonna end? 1:45. No ands, ifs, or buts about it, okay? So double check, make sure your Chromebook, the charger works, you know where it is, that, you know, you can log in, and I posted, it'll post exactly where you're gonna, but you're gonna go to formative, I think it's goformative.com, and it'll post where you need to go. And then the test is AL matter test. Alright? And I will clarify that. But you need to send me, if there's any issue at all, you logging in, you need to send me an email immediately. Okay? Because I'll start everybody here, and then I'll be at my desk, and I'll be able to answer an email and direct you and make sure that there's not an issue. Okay? This is the first time I've ever used this program. Okay? I got my tutorial this afternoon on how I needed to do this, and they promised me, I've scheduled it to open up at 1. And you guys, then I'm supposed to post the link and give you exact directions on what to do. But I'm still not sure I have it all set up right. So I am going to double check with the teacher before I leave to make sure it's all right. Or actually, I'll probably do it 4th period tomorrow just to make sure it's all set up and good to go. All right? You shouldn't be nervous about this test if it's open note and you just went through it.